Hey everyone, Mr. Skelton here. We're back at it. Lesson 9, and this is Unit 4. And today we're going to be talking about two things. We're going to be talking about the irrational root theorem and the imaginary root theorems. So we'll kind of highlight the important parts here. So call this number 1, number 2. In Lesson 8, just for review purposes, Lesson 8, we talked about the rational, right? Rational root theorem. And we talked about, if you remember, like P over Q, we listed all the factors. So if I had something like y equals, 6x to the third plus 4x minus 5, we would take all the factors of 5, which would be plus or minus 1 and plus or minus 5, and we put it over all the factors of the leading term, which is 6. It would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And those were all of our possible rational roots. And that's what we did in Lesson 8. And so today we're going to be talking about the irrational root theorem and the imaginary root theorem. Okay? Just so you don't get super confused, I want to make sure, I don't know if I explained this to you yesterday or in Lesson 8, but we call rational root, when you see this word root, don't forget that in math, sometimes I think, it's my opinion, I feel like we tend to make things more challenging than what they need to be. You think about all the ways that we have solved polynomials or quadratics. We call them zeros, we call them roots, we call them solutions, we call them the x-intercept, like when we graph them. All of these mean the same thing. They're solutions, okay? They really are. They just, in math, again, we try to make things sometimes, I think, a little bit more complicated. But when you see the word find a zero, that really means find an answer. Find all the roots. That means find the answer. Find the solution, obviously, speaks for itself. Find the x-intercepts, right? When we solve by graphing, if you recall, when we solve by graphing, we're looking for where the polynomial crosses the x-axis. That's an x-intercept. That's also a zero. So when you see these words, I think sometimes in math we got to interpret the language. So Lesson 8, rational root, rational things that we can write as fractions. Today we're going to be talking about irrational root and imaginary. So there's a little background information for you on that. All right, so let's just jump right into it here. We have two theorems of the day. So basically what we have going on here is this. The irrational root theorem says if a plus the square root of b is a solution, then so is a minus the square root of b. And so this is the irrational root. So irrational numbers, things like the square root of 2, or we could have 5 plus or minus the square root of 7. Those are examples of irrationals. Okay? And so if you think about this, when we have square roots, that means we're coming from the quadratic realm, right? And all of these are plus or minus. And so basically what the irrational root theorem is saying is that if you have 5 plus the square root of 3 as an answer, then you have to have 5 minus the square root of 3 as an answer, because it's a quadratic and it's always going to be plus or minus. All right? We use this word, you can see that these numbers are the same, right? 5 and 5, 3 and 3, but the only thing that's different is the sign. In math, we call that the conjugate. All right? And so you're going to probably see that word, you'll hear me refer to it, but if I had a plus the square root of b, then its conjugate would be a minus the square root of b. If I had 5 plus the square root of 3, its conjugate would be 5 minus the square root of 3. Again, it basically just means opposite sign. That's what that conjugate means, okay? Just like with quadratics, when we have imaginary numbers, if you think about when we had, if you take an example like x squared equals negative 4, right? When we went to solve this, we'd get x equals plus or minus 2i. And anytime we had imaginary numbers, you got to think about, okay, if we have imaginary numbers or imaginary roots, how did we get that? We got that by square rooting a negative number, which leads to plus or minus. So it's the same exact theory. If you have a plus bi, then its conjugate of a minus bi has to be a solution, okay? So another way you can kind of bring this all home is that whether you have an irrational or imaginary, you're always going to have a plus or minus with both of those, okay? So let's apply it, and maybe it'll kind of come together for you here a little bit better. All right, so they're going to try to mess with you here in the questions. They're going to say, find a cubic. So in my mind, and when I read this, I'm thinking, okay, something, cubic, x to the third polynomial, that has the following solutions. Well, we know there's supposed to be 3 solutions for cubic. They only list 2. You have to look at this and say, okay, I have 3, which I have x equals 3 as a solution. I have x equals I as a solution. But if I have I, what myself or the author of a workbook or quiz or a test, they want you to know that negative I, or the conjugate of I, has to also be that third solution, because we need 3, right? So you have x equals negative I. And so you want to find a cubic polynomial, so what you're going to end up doing is writing this in standard form. So we're going to take this all the way backwards. We've done this before. We've given you zeros, and you've worked backwards, and we're going to do the same thing here. So just work this backwards. Subtract 3 and get the factors. So this factor would be x minus 3. Subtract the I, get x minus I. Add this I and get x plus I. Okay? Now, when you're multiplying these, I know you have 3 factors. When you have the imaginary or the irrationals, multiply these together first, and then take the x minus 3 and go through second. So I'm going to FOIL this out. So I'm going to get x squared plus ix minus ix. We usually go in alphabetical order, but you can go xi, since I stands for the imaginary, really doesn't matter. So I got x squared, xi, negative, and then I have a minus I squared. So the middle terms cancel out. Negative I squared, or minus I squared. Remember that I squared is negative 1, so you really have minus a minus 1, so you have x squared plus 1. Now, some of you may have some really good number sense about you, and if you see plus or minus I, which essentially that is, and you just work that all the way backwards, some of you will get to this because you know if you subtract 1 and take the square root, you're going to get plus or minus I. If you can't, and you need to go through the multiplication process, then so be it. And then we're going to take this x minus 3 and go through it. So x times x squared is x cubed plus x minus 3x squared minus 3. So I'm going to get x cubed. We always want to write it in standard form, so I got to put my x cubed, x squared, then plus x, and then minus 3. And there is the cubic function that yields 3 and plus or minus I. Okay? All right, if you look at number 2, sometimes this can get a little confusing. Some of you may look at this that I did and think that this is an extra step. And if you don't need that, don't worry about it. But I like to put this step in there for problems that are like this. So again, it says find cubic. So what are we thinking? We're thinking something x to the third. So we're thinking 3 solutions, right? So it says find a cubic polynomial that has the following solutions, negative 1 and 2 minus I. Well, obviously we need its conjugate. Its conjugate would be 2 plus I. So those are your 3 quote-unquote roots, zeros, solutions, etc. So I'm going to work this backwards, right? So I'm going to write this as a factor, so that's going to be x plus 1. Now this is where it gets a little tricky, right? This is really x equals negative 1. I have x equals 2 minus I, and I have x equals 2 plus I. Well, basically what I want to do is I want to subtract this to the other side. So I have x minus 2 minus I, and I would subtract this whole quantity and have x minus 2, right, plus I. And what I need to do is I need to run this minus sign through here. So I'm basically going to get this x plus 1, and then this becomes x minus 2 plus I, and this becomes x minus 2 minus I. Okay? And so then I'm going to have to distribute. Like I said, I would focus on this part first here, all right, and multiply these together. So I'm going to get x times x, which is x squared. I'm going to get minus 2x. I'm going to get minus xi. I'm going to have a minus 2x plus 4 and a minus 2i. And then I'm going to have a positive xi. I'm going to have a minus 2i. And I'm going to have a minus I squared. Now, This looks a little messy, so let's go through and take a look at, see if we got anything that's going to cancel itself out, and let's kind of simplify a little bit here. Let's see, I got x squared, I got my minus xi and positive xi, so those are going to cancel. Notice in this one I went xi, and the one above I went ix, so it really doesn't matter as long as you stay in order. I have a minus 2x and a minus 2x, so it's going to be a minus 4x. I have a negative 2i and a negative 2i, so that's a minus 4i. I got this positive 4. This is a negative I squared, so that's really this. That's going to be a plus 1. So plus 1 and 4 makes plus 5. Okay? So I have that whole thing, and then I still have this x plus 1 that needs to get distributed through on that. Okay? And so I should get, let's see. Oh, I must have made a mistake on this. Let's see, x squared, negative 2x, negative ix, negative 2x, positive 4, positive 2i, right there. That makes sense. I found my mistake. Sorry about that. I was like, wait a minute, I shouldn't have a 4i there. If you see you probably heard me thinking to myself in my head here, that's supposed to be a positive 2i, and my let's see, negative 2i will cancel out. So this is good. I'm kind of glad this kind of happened, right? If you're working through this problem, your i's should all cancel out when you do this, because we're trying to come up with a polynomial that yields these answers. We're not going to come up with a polynomial that has imaginary parts to it. So kind of went back and self-corrected there real quick. Sorry about that. So then we're going to finish up with the x plus 1. So that's going to be x to the third minus 4x squared plus 5x, and then distribute the 1 through, plus x squared minus 4x plus 5, and then put all my like terms together here, so x to the third, I have a minus 4x and a positive x squared, that's a minus 3x squared, 5x and 4x make a positive x, and then plus 5. Okay, and there's my cubic polynomial that has the following solutions. All right, last page here. This one says find a 4th degree polynomial with the roots I and negative 2i. Why don't you go ahead and hit pause and try this on your own, see what you come up with, and then we'll check our answers. Okay, so 4th degree, right? So what are we thinking? We're thinking, okay, I got to have 4 solutions. So right now they're only giving me 2, so what are the conjugates? First of all, this is I, so I know I'm going to have a negative I in there. It's a negative 2i, so I know I'm going to have a positive 2i as a solution. So I'm going to go ahead and write this as x equals I, x equals negative I, x equals negative 2i, and x equals 2i. And then I'm going to go backwards and write these as factors. X minus I, x plus I. This will be x plus 2i, and x minus 2i. Okay? Now, you can, what I would suggest you do, if you want to go this the long road here, is multiply those two together, multiply these two together, and then multiply those two answers together to get your 4th degree polynomial. But let's have some number sense about us. Let's use our brain a little bit and think about this. If you work backwards, right, what would give you a plus or minus I as an answer? So in my mind, without doing the multiplication, I'm thinking, okay, if I got x squared equals a negative 1, and I go to square root both sides, that's going to give me my plus or minus I. So if I just add this 1 over, I'm going to have x squared plus 1. So that's the polynomial. If I multiply these two in blue together, I'm going to get this. Likewise here, what gives me an answer of plus or minus 2i? In my mind, I'm thinking that's the square root of negative 4, right? So how did I get the square root of negative 4? Take it back one more step. That would mean x squared would have to equal negative 4, because I'd have to square root it, and then just add the 4 over, and that gives me x squared plus 4. So yeah, you can go ahead and FOIL all this out, and you can do all that, but if you have some number sense about you, and you can kind of see it working backwards, you can save yourself a little bit of time. Now, I still have to multiply these two together, right? So x squared times x squared is x to the 4th. That's going to be 4x squared, and then that's going to be plus x squared and plus 4. So I'm going to get x to the 4th plus 5x squared plus 4. And that is going to be my 4th degree polynomial with the roots. Okay? So again, just to recap, now with the 2 lessons that we've done, we've covered rational roots and all the possible solutions that we can get for that. Remember, we did synthetic division to test those out. And now today we're talking about the imaginary root and irrational roots, and just making sure we understand that the conjugate is always in play when you're given one. So if you take your time through these, I think you should be okay. Also, if you have some good number sense about you, and if you're learning, and it'll come, the more you practice, I think you can save yourself some time on these. As always, if you have questions over these notes, please ask away, and I look forward to helping you out in class, okay? Take care.